Okay, so picture this. You're an alien just landed on Earth, and you look up,
Oh, this is gonna be good.
and what do you see? A bright blue sky. You'd probably be pretty confused, right?
Yeah, I mean, space is black. The sun looks kind of yellow from here. Where'd all that blue come from?
Exactly. It's a question we rarely even think about. But today, we're diving deep into the science behind why the sky is blue.
And not just that we're going to tackle those fiery sunsets, too. You know, those red and orange hues that paint the sky as the sun goes down.
So let's get right into it.
Hmm.
When we talk about sunlight, we often think of it as just plain white light, but it's actually way more complex than that, right?
Right. Sunlight is actually made up of all the colors of the rainbow, kind of like when you see a rainbow after a rainstorm.
Oh, I see, yeah.
Each of those colors represents a different wavelength of light, and each of those wavelengths interacts differently with our atmosphere.
So it's like sunlight's got a hidden secret identity as a rainbow, just waiting to be revealed.
Exactly. And the key to unlocking that secret is something called Rayleigh scattering.
Rayleigh scattering. Okay, that sounds kind of complicated. Break it down for me.
Basically, imagine sunlight hitting the Earth's atmosphere like a bunch of tiny marbles bouncing around.
It's like a cosmic game of marbles.
Yeah, now those marbles representing the different colors of light, they collide with air molecules in the atmosphere. And here's the thing. Shorter wavelengths of light, like blue and violet, they're like those super bouncy marbles they scatter all over the place when they hit something.
Ah, so they're bouncing off all the air molecules, making the sky look blue.
Precisely. The longer wavelengths, like red and orange, they're more like those heavy marbles. They don't scatter as easily, so we don't see them as much.
But wait a minute. If violet light scatters even more than blue, why don't we see a violet sky?
Great question. It all comes down to our eyes. Our eyes are actually much more sensitive to blue light than violet.
Mm.
So even though there's more violet being scattered around, we just don't pick it up as well.
Ah, our eyes are playing favorites with the colors.
You could say that. So we perceive the sky as blue because that's the scattered color our eyes are best at detecting.
So that explains the blue sky. But what about those fiery sunsets? Why does the sky change color when the sun starts to set?
It's all about the journey that sunlight has to take through the atmosphere. Think about it. When the sun is high in the sky, the light has a relatively short path to travel.
Right, it's like a quick commute.
But as the sun dips lower on the horizon, that light has to travel through a much thicker layer of atmosphere to reach our eyes.
Ah, so it's like rush hour for the sunlight. It has to fight its way through all that extra air.
And in that fight, those shorter wavelengths, the blues and violets, they get scattered so much that they're practically gone by the time they reach us.
So they get lost in the crowd.
Exactly. But the longer wavelengths, those reds and oranges, they're strong enough to make it through all that atmospheric traffic.
They're like the big trucks that just keep on going.
And that's why we see those stunning reds and oranges dominating the sky at sunset.
Now remember those incredible sunset photos after the Krakatoa volcano eruption in 1883? Those colors were just unreal.
Yeah, those vibrant sunsets were caused by all the dust and ash that Krakatoa spewed into the atmosphere. Those particles acted like a million tiny mirrors, scattering the sunlight even more, which made those reds and oranges even more intense.
It's amazing how those tiny particles can have such a dramatic effect on something as grand as the sunset.
It really is. And speaking of other worlds, did you know that Mars actually have blue sunsets?
Wait, what? Blue sunsets on Mars. How is that even possible?
It's pretty wild, right? So during the day, the Martian sky often looks reddish because of all the iron-rich dust that's floating around. But at sunset, when the sun is low, the light has to pass through a thicker layer of that dust. And you guessed it, the longer wavelengths like red get scattered away, leaving behind a bluish hue around the setting sun.
That's mind-blowing. It's like the complete opposite of what we experience here on Earth.
The universe is full of surprises.
Before we wrap up, I gotta ask about the legendary green flash. Have you ever seen it? Is it really a thing?
The green flash is definitely a real phenomenon, but it's super rare and only lasts for a second or two. You need perfect conditions for it to happen, basically, when the air is really clear and calm.
So what actually causes it?
It all comes down to how light bends or refracts as it passes through the atmosphere. Think of it like looking at a straw in a glass of water. The straw appears bent because the light is bending as it passes from water to air.
Ah, I get it.
So at sunset, as the very last sliver of the sun dips below the horizon, the Earth's atmosphere acts like a giant prism separating the colors of the sunlight. And for a split second, that green light gets refracted just the right way to create a visible flash.
Wow, that's incredible. It's like a little hidden treasure at the edge of the day.
You could say that.
So folks, next time you look up at the sky and see that brilliant blue or catch a fiery sunset, Remember, it's all thanks to this amazing phenomenon called Rayleigh scattering. It's the way light interacts with our atmosphere that paints these breathtaking colors above us.
And don't forget those blue Martian sunsets. It makes you wonder what other incredible sky shows are happening out there in the vastness of space.
That's a great point. So keep looking up, keep questioning, and keep exploring the wonders of our universe, big and small.
Okay.
Thanks for joining us on this deep dive, and until next time, stay curious.
Absolutely.
And keep those questions coming. We love diving down with you.
Yeah. See you next time.
Bye.